Welcome! Today we are diving deep. We're going to decode the debate around life's most fundamental blueprint, DNA. And this isn't just about biology. We're exploring a huge question about information, complexity, and really where it all comes from.
So, everything we're about to discuss really hinges on this one question. We talk all the time about the genetic code, right? But what if that's not just a handy metaphor? What if life is literally written in a digital language? Pondering that question seriously opens up at least 3 totally different ways to understand biology, belief, and maybe even the origins of life itself.
Okay, so before we jump into the different arguments, we have to start with the one fact that everybody, and I mean everybody, agrees on. This is the observation that kicks the whole thing off. This is absolutely crucial to grasp. Your DNA uses 4 chemical bases. You know them, A, T, G, and C. But they aren't just a jumble of chemicals. They're symbols, discrete characters in a 4-letter alphabet. It's almost exactly like how a computer uses zeros and ones to store information and run programs. Your cells are using this 4-letter code to build and operate you. It's a biological operating system, complete with data processing and even error correction protocols. Wild, right?
Well, you can imagine the discovery of this incredibly sophisticated digital information, all packed inside a tiny molecule, led some scientists and philosophers down a pretty controversial path. It's a theory called intelligent design. So what exactly is intelligent design, or ID? At its core, it's an argument from inference. The proponents say, look, just like you can look at a line of code or an ancient pyramid and know it was designed by an intelligence, we can look at certain systems in biology and infer the same thing. They're very clear that they see this not as a religious belief, but as a scientific conclusion based on specific, measurable features they find in nature. And the main feature they're looking for is something they call complex specified information, or CSI for short. Here's a simple way to think about it. If I just type a random string of letters like GBLKPQZ, that's complex, sure, because it's random and unlikely, but it's meaningless. Now, if I write the code of life, that's also a very unlikely complex sequence of letters, but this time it's specified. It follows the rules of English and it carries a clear message. Proponents of ID argue that DNA is just packed with this kind of information. It's both incredibly complex and highly specified for biological function. The other big idea here is irreducible complexity. The classic analogy is a mousetrap. You know, you've got the wooden base, the spring, the hammer, the little catch. You need all of it. If you take away just one of those parts, you don't get a mousetrap that works half as well. You get a non-functional pile of parts. It just doesn't work at all. The argument is that some molecular machines in our cells are exactly like this, and that poses a real challenge to the idea that they could have evolved in a slow, gradual, step-by-step process. To try and make this a rigorous scientific process, proponents use a framework called the explanatory filter. It's a 3-step process. First, they ask, could this feature be explained by a simple repeating law of nature, like how a snowflake forms? For something like DNA as code, they say no. Then they ask the next question, okay, could it be explained by pure chance? If the odds are just astronomical, they say no again. It's only after ruling out both law and chance that they feel justified in inferring the third and final option, design. And speaking of astronomical odds, just look at this number. According to calculations made by ID proponents, this represents the probability of a single, relatively short functional protein forming by random chance alone. Let me put that into perspective for you. There are only about 10 to the 80th power atoms in the entire known universe. So a number this impossibly small, they argue, basically takes chance off the table, forcing them to that final step in their filter, inferring design. Okay, let's make this more concrete. We're going to look at a practical example now. The most famous, most debated biological system in this whole conversation. It's a tiny, microscopic motor that has become the absolute poster child for irreducible complexity. Meet the bacterial flagellum. This thing is literally an outboard motor for a bacterium. It's got a propeller, a drive shaft, a stator, a rotor, the whole shebang. And it can spin at up to 100,000 RPMs. Now, it's built from about 40 different protein parts, and here's the ID argument. This is the mousetrap in action. It's irreducibly complex. Take away any one of those essential parts, and the motor doesn't just get slower, it breaks completely. The bacterium can't swim. So, the question is, how could something like this possibly evolve step by step if any of the intermediate stages would have been useless? And that brings us to the mainstream scientific counterargument, which centers on a fascinating process called co-option. As it turns out, a big part of the flagellum's motor looks almost identical to another, simpler machine that already existed. It's called the Type 3 Secretion System, or T3SS. The T3SS is basically a molecular syringe that some bacteria use to inject toxins into other cells. And what do you know? It shares about 10 of its core protein parts with the flagellum. So the evolutionary explanation is that nature didn't have to invent the flagellum motor from scratch. It could have co-opted or borrowed the parts from the T3SS and then built upon them for a new function. This is a direct challenge to that all-or-nothing idea of irreducible complexity.
But hang on, because this isn't just a two-sided fight between intelligent design and mainstream evolution. There is a third way of looking at this, a theological perspective, that comes in and reframes the entire question. It basically argues that both sides might be missing the forest for the trees. This perspective comes from a reinterpretation of the Islamic concept of taqdir. Now, a lot of people think taqdir means fatalism or predestination, but this view argues that it really means the measure or the pattern, the set of fixed, measurable, and discoverable laws of nature that a creator established from the very beginning. From this viewpoint, things like physics, chemistry, and biology aren't random. They are the direct expression of this perfect, unwavering cosmic pattern. The laws themselves are the real masterpiece.
This sets up a fascinating contrast between two very different ideas of a creator. The intelligent design argument, whether it means to or not, can imply what's often called a god of the gaps, a designer who has to step in and manually tinker whenever the laws of nature fall short. But this other view proposes a god of perfect law. This creator's genius isn't shown by intervening, but by designing a set of natural laws so flawless, so self-sufficient, that they can generate all of life's incredible complexity all on their own, with no need for further meddling.
And this quote just nails the core of that theological critique. The argument here is that a creator who has to keep stepping in to fix things is by definition a creator who designed a flawed system to begin with. A truly perfect creator, this view suggests, would design perfect laws that get the job done right from the outset. So from this perspective, evolution isn't some random process that challenges the idea of design. It could be the very mechanism of that perfect design, playing out exactly as intended.
So where does all this leave us? Well, we've basically walked through three very different lenses, three completely different frameworks for looking at the exact same biological fact, the absolutely stunning complexity that's coded inside our DNA.
So let's just do a quick recap. First, you have intelligent design, which sees direct assembly by an intelligent agent, a designer who intervenes in the gaps left by natural laws. Then you have mainstream science, which proposes gradual evolution through mechanisms like co-option and natural selection, and it remains, by its own rules, silent on the ultimate question of a designer. And finally, you have this rational Quranic theological view, which sees all this complexity arising through self-organization, all thanks to perfect, God-designed natural laws. Here, the designer is the architect of the whole self-running system. And that really brings us to the final big question for you to think about. When we look at the breathtaking machinery of life, what are we actually seeing? Are we looking at a finished artifact put together piece by piece by a tinkerer? Or are we witnessing an ongoing, unguided natural process? Or could we be seeing a sign, something that points beyond the thing itself to the sheer elegance of the underlying laws that make it all possible? In the end, what you see depends entirely on the lens you choose to look through.